All right. And so here's one that is amazing to me that you can do this. You can de-blur images. And what you do is you download some images, and these images are from a data set that people put up to show different cameras. They took various models of cameras and deliberately took sharp and blurry images of the same photographs of the same object and then uploaded them. So if you import the images and then look at them, here's what they look like. There's a picture of some ceiling here with a chandelier, and then they blurred it. So you have a pair of images, sharp and blurred. So again, this is labeled data. If you want to look at it that way, it's supervised learning. You're going to try to de-blur this image, and you know what the right answer is. So you split the data set into training and test portions as before, and then you prepare an encoder and a decoder and train the model. And when you train the model, it's going to have 34 million parameters. It's by far the biggest model we've done because remember, this is taking a real image, 3 colors, and I think some like 256 by 256 pixels, a lot of data in this image, and quite a job to de-blur it. And so the first thing you do is train it for 5 epochs of training, and that will take 5 minutes. That's why I'm not doing it live. And if you do that, you'll find a flag, and then you'll see the results. And the results are, after 5 minutes of training, the results are terrible. Here's a blurry image it's never seen before. Now, I guess this is blurry. Here's the right answer, and here's what the model produced, which is horrible, because 5 epochs of training is not enough for this model to get good at it. And what you can do is turn on the GPU. Now, if at some point, Google will no longer let you use a GPU for free. When I first did this, I used the CPU, and then it takes like 74 minutes of training to do 100 epochs, which I was still pretty amazed at. But if you turn on the GPU, switching a runtime type inside there, then you get a GPU, and then it will train with 100 epochs in only a few minutes instead of taking 70 minutes. And after 100 epochs of training, it actually gets pretty good. You show it this blurry image, and the model produced that when the right answer is that. And as you can see, it actually did pretty much de-blur it, which is amazing. So that's a realistic one to play with. Doing a realistic task. I see this in all the TV shows. They have a surveillance camera, and they see like a license plate or a face, and it's blurry, and they say, de-blur that. And they run it through some machine learning model that de-blurs it. But another thing to remember is it's not necessarily accurate. You don't really understand how it works. So it's sort of guessing when it fills in things. So if you were to see a blurry license plate and it turned into a sharp license plate, that's nice, but you should realize it's not perfect. And I guess if you had license plates, you could test it and get some rating on the perfection, but it will probably just make a look like a real license plate, even if it's wrong. And like we see, large language models will produce an answer that looks good, even though it's completely wrong. And I would imagine this would do the same thing. So that's one of the many deceptive things about machine learning models. They don't fail gracefully. They just lie convincingly. I'm going to stop this one.